Hello everybody. In this video I'm going to be going over problem number 23 out of 25 of the AMC 12B from 2006. So this is the later problems, so I stressed that it was like out of 25, so that this is more the difficult side. So we have an isosceles right triangle here, so this is a right angle, and we have a point P inside of it, and we're given the lengths of all these segments. So PC is 6, PB is 7, and PA is 11. And what we want is to find um, the length of one of these sides. So like we said, isosceles triangles, so these both have the same length, and we want to find that length. Um, and basically, it's given in this format. Um, and this looks like a very weird configuration. So obviously we know like an angle here, right? That's 45 degrees. Other than that though, we're not given that much information because we could, law of cosines easily if we knew this angle or even this angle or even this angle. And looking at it, there's probably a way to law of cosines all three and then combine it, maybe. But one way to do it, and which is the way I did it, is to rotate this entire triangle around this vertex C. And in that way, we get, um, so try and make it as good as possible. And so we do it, um, let's see. So we want to do it so that this basically extends out another length of S. So we get another isosceles right triangle. So this is S. So these two side lengths are congruent. And we also rotate this stuff. So this point P gets reflected or not reflected, but rotated. So we're rotating it, and it's rotated such that it'll form a 90-degree angle here. Maybe like that. I know this isn't a to scale diagram, so I guess I shouldn't worry too much about making it accurate. So this point P is rotated somewhat like this to another point here. So I'll call it P prime. And this length is, oh god, that was bad. This length is 6, this length is 7, and this length is 11. So it's sort of just flipped around, and we know that we know that ACB is a right angle, but now we know this angle right here, PCP prime, is also a right angle. So if I draw that in, like that, and I'll go back to the darker color. So we have an isosceles right triangle right here. So this is, oops, it's on ruler mode. So this length right here is 6 root 2. My goodness. Just from a quick Pythagorean theorem, if this side length 6, if this side length 6, Pythagorean theorem says this is 6 root 2. Now we have this triangle BPP prime, and it's got side lengths 11, 7, and 6 root 2. You might be wondering, what's special about that? And it turns out, well, 7 squared is 49, and 6 root 2 squared is 72, because it's 6 squared times 2, and that equals 121. Well, that's 11 squared. And the converse of the Pythagorean theorem tells us that this must be a right angle. So now we have this interesting shape, which is an isosceles right triangle with another right triangle on top of it. And what that tells us, so I'm going to erase this side length and make this darker. So this BC, right, this length that we're looking for is across, or is one of the legs, or one of the lengths of a triangle with legs 7 and 6, and this angle right here is 45 degrees, and this is 90 degrees. So that tells us that this entire interior angle, I'm kind of erasing a lot every time I erase, this entire interior angle, whatever it is, if we call it x, this x is 135 degrees because it's 90 plus 45. The 45 coming from this isosceles right triangle. And if we know the angle in between two side lengths, and we know the side lengths, we can find this BC, right? So BC is S, which is the length we want. So S squared, and this is the law of cosines, is 49 plus 36 minus 2 times 42 times cosine x. So, but cosine x, if x is 135 degrees, is negative 1 over the square root of 2, or equivalently negative square root of 2 over 2. So the factor of 2, which is in the factor of 2 and the negative will cancel out. So we just get square root of 2 times 42, which is 6 times 7. And we've basically got it in this format now. So it says that s is equal to the square root of a plus b root 2. So if I just took the square root on both sides, then this would be my a, and this 42 is my b, and the problem requests that we add it all up. So 49 plus 36 is 85, and plus 42 gives us 127, and that is answer choice E, and that is the answer to the problem. I hope you enjoyed this. I know the diagram's a little messy, um, and I hope this enlightens you to how rotations can be very useful in geometry problem solving. Thank you, and I hope to see you in my other videos.